Alright, so this notes video will be on special right triangles, and we're going to find out what is so special about them. So just had a joke up here. Some triangle taking his triangle girlfriend out, and they said, "I don't know, Sam, something about that boy just isn't right." Ha! Okay, so now we're going to get into it. Special right triangles are similar. We just finished our unit on similarity, and similarity is really what trig is based on. So, and then special triangles are going to lead us into trigonometry. So special right triangles are similar, and there's two different types that we commonly use. One is called is referred to as 30, 60, 90, and the other one is referred to as 40. So I've given each of the side lengths a measurement of 1, and if we dropped a perpendicular that bisected this angle right here, it's also going to bisect the opposite side here. So I've labeled the side that we'll be using for our right triangle as 1/2. This side was not broken up at all, so it's still 1. And then this is a side that we're going to actually solve with Pythagorean theorem. So we start with a squared plus b squared equals c squared. I want you to think about which sides we have. Are we solving for c, or are we solving for one of the legs a or b in this problem? So hopefully you came up with, we're actually solving for a or b. I've left it as b, but you could use either one. And what I've done is plugged in our leg, 1/2, into a spot, and then our hypotenuse, which is 1, into c spot. And I'm just going to go through working this out. So when I square both of these, I end up with 1/4 plus b equals 1, and just to show where that 1/4 comes from, if we square 1/2, we have 1/2 times 1/2, we multiply the numerators and we get 1, multiply the denominators, we get 4, so 1/2 squared is 1/4. So if I keep going through solving, I'm going to subtract 1/4 from both sides. I've also shown the work for this over here by converting this 1 into fourths, which is 4/4, and then if I take away 1/4, then I'm left with 3/4. So b squared is equal to 3/4, and then finally when we square root that, we get the square root of 3/2. Now when I square root a fraction, I can break apart my square roots if we're using multiplication or division. So I can apply the square root to the top, square root of 3, which cannot be simplified. That's why I've left it as square root of 3. But the square root of 4 is a perfect square, so we leave that as 2. So we've just used Pythagorean theorem to show what the third side would be. And basically what we're going to use this in is, so here's like what we just came up with, and we're going to take that and put it in a general form, and this is kind of like a guideline for any 30, 60, 90 right triangle. So you're probably wondering, like, how did we get from 1/2 to just x? How did we get from 1 to 2x, and from 3 to square root of 3/2 to x squared root of 3. So actually what we've done here is to just make things a little bit more simple. We have taken each of these things and multiplied them by 2. So if I multiply by 2 right here, 2/1, I get 2/2, which is 1. Okay, if I multiply by 2 over here, 2/1, these 2's can cross cancel, and I just end up with square root of 3. And then if I multiply by 2 over here, 1 times 2 is obviously 2. So if you kind of see the common theme is this is like our shortest side, and it's going to be called our x. So this shortest side, I mean, any of these sides can change, so we're kind of writing it as a ratio. So it's a ratio of the sides, a relationship that the sides will always have. So in our case here, our shortest side was 1. To get the hypotenuse from that shortest side, you just take it and multiply by 2. So that's why if our shortest side is x, we multiply that side by 2, and we get 2x. And then finally, this we ended up with square root of 3. Really, we could say that there is a 1 in front of that square root of 3, and so this was x times square root of 3, which is what we have here. And again, we're just basing off of whatever the shortest side here is going to become like our base value, and then we use that value to find the other two sides, and we may be working backwards from there. So we're going to look at an example where we're actually applying this right now. Okay, so it says to solve for the unknown sides. And what I am going to do first, is I'm just taking that general form that we just figured out, and I'm going to write it in next to the triangle. So we have our 2x right there, our x, and then our square root of 3x, or x squared root of 3. So notice that x is always the shortest side, because if I have x here, multiplying that x by 2 is obviously longer, and multiplying that x by square root of 3 is also longer. So our shortest side x is always across from our shortest angle, which is 30. So this is really important when you're identifying like which sides you have. We do not have our base value x. If we did, we could just simply take that, multiply, and get the other ones. But what we have is 14, and we know that it's formatted in 2x. So what I've gone and done is just set up an equation to represent that. So I want to figure out what my x is so I can find these other two sides, because they are based on that value. So if I know that 2x is equal to 14, I have to think, what did I multiply by 2 to get that answer 14? You could probably come up with it in your head, but sometimes an equation is helpful, and I'd like you to just have it in your notes as an example. So when we solve for x, we get 7. So now that I actually have that base value, I know that this side with x is going to be 7. And then over here, I just simply take my 7 and multiply it by square root of 3. I've put the 7 square root of 3 in the front, the 7 in the front, because we always put whole numbers in the front. So depending on what side you're given, you may have to like find out what x is first, which we did here, and then you're using that x value to multiply and get the other sides. Okay, so next type of special right triangle we're going to go over is the 45, 45, 90. So just like I've done on the last one, I'm starting with a square this time, and I'm splitting the square diagonally, which we know that a diagonal does bisect opposite angles on a square. So I've marked that both of these angles are 45, and I'm just starting kind of with that same value of having all the side lengths be 1. Just like we did on the equilateral triangle, except for now this is a square. So you notice this is actually an isosceles right triangle. So any isosceles right triangle is always going to be 45, 45, 90, because think if one angle is 90, I subtract 180, take 90 away from 180, I'm left with 90, and these two angles have to be the same, so they are always going to be 45 on an isosceles right triangle. So again, using Pythagorean theorem, this time I want you to think about which side I'm solving for. It's different than the side we were solving for last time. And if you notice, we're across from the right angle right here, so we are solving for C. So I plug in my legs, and then I just go through simplifying. I get 2 equals c squared, and then I of course have to take the square root, and so I get the square root of 2 is c. So just like we did with the 30, 60, 90, now we're going to take that and put it into a general form. So here's the general form. We just figured out that if we have a side length 1, a side length 1, then the hypotenuse is going to be square root of 2. So basically our base value, our shortest side, well, it's the same thing right here, 1 and 1. So when we translate that to like a general form, we have side lengths x and x. Now those could change. It could be 1, it could be 5, it could be 100, but we're always going to have this same relationship between the sides because all these 45, 45, 90 triangles are similar, and we know that similar triangles are proportional. So we have two sides x, they're the same, and then the hypotenuse is always going to be that value times square root of 2. Okay, so now for an example, again, we're going to solve for the unknown sides. And if you notice here, just like on the 30, 60, 90, we don't have that base value. That base value x is actually one of these two legs. So I'm going to take my general form and write it in. So we get x, and then x squared root of 2. So, and you know, it's helpful to take that and copy it down anytime you come up with one of these problems. So I know that this 10 that I'm given is formatted as x squared root of 2. So I'm going to have to work backwards to find out what that x is. So just like last time, set up an equation because like in this case, the equation is helpful. So I know that 10 was found by taking x squared root of 2. So now if I solve this equation, I would divide both sides by square root of 2. And I end up with x equals 10 over the square root of 2. Pretty simple. Now we just have to go one step further, and we call it rationalizing this because it's pretty common kind of way to do things in math is to not keep a square root in the denominator. Now there are times when you do, but we want to know how to rationalize. We may see our answers on the end of course rationalized. So the way you get the square root out of the denominator is by whatever that square root is in the denominator, you're always just going to multiply the numerator and denominator by that number. So I'm taking the numerator, multiplying it by square root of 2, and then denominator multiplying it by square root of 2. And kind of the purpose of this is if I'm multiplying by square root of 2 over square root of 2, this is really just 1. So I'm not changing the value of my x, I'm just changing the format of it. And then we've kind of done some problems like this anytime you square a square root. So then I end up canceling those squares. Like it's square root of 2 times square root of 2, which ends up being square root of 4, which really we're just left with 2. And then these I would just, you know, multiply together on the top. So 10 square root of 2 over 2. We're going to have a lot more practice with this. So if you're a little bit unsure of you know, how you would do that on your own, we're definitely going to get some examples in class. So now I know that my x value is 10 square root of 2 over 2, and really both the sides are the same, so from there I just know that the two remaining sides will be that value. So I bet that some people have questions on this, so if you did have questions along the way, kind of jot them down in your notebook somewhere so we can have a discussion in class about them, and I will see you then.